This is Geometry Lesson 6-1, the Polygon Angle Sum Theorem. We've got two objectives for this lesson today, that you will be able to find the sum of the measures of the interior angles of a polygon, and that you will be able to find the sum of the measures of the exterior angles of a polygon. Pause this now and get that objective copied. Okay, so there's an important piece of information that the sum of the interior angles measures of a polygon depends on the number of sides a polygon has. So what we can say is that by dividing a polygon with n sides, you need to fill that in, into n minus 2 triangles, you can show that the sum of the interior angles, those are inside angles, of any polygon is a multiple of 180. And in fact, the polygon angle sum theorem right here says that sum of the measures of the interior angles of an n-gon is n minus 2 times 180. You've got a fancy box to put that in. Write that down. So we're going to use this a lot over this chapter and then actually a little bit into second semester as well as we talk about polygons. All right, so finding a polygon angle sum. It says, what is the sum of the interior angle measures of a heptagon? Well, it might be useful to know how many sides a heptagon has. Well, we've got triangles are 3, quadrilaterals are 4, pentagons are 5, hexagons are 6, and heptagons are 7. Octagons are like your stop signs, those are 8. Nonagons are 9. Decagons are 10, and dodecagons are 12. We are going to talk about those like we assume you already know what they are. So if you get to a problem on your homework and you're not sure how many sides it has, look it up. All right? So if it is a heptagon, that means that n, the number of sides, is 7. So we're going to use our formula n minus 2 times 180, and we're just going to plug in that 7. It goes 7 minus 2 times 180. Now, if you just type into your calculator 7 minus 2 times 180, you are not going to get the correct answer. Use the order of operations, plug in, figure out what 7 minus 2 is first. That gives you a 5 times 180. Now multiply 5 and 180 and you get 900. Now, if you don't have a calculator right now, this would be a great time to pause the video and get yourself one. Since this is notes, you may use your calculator on your cell phone. Or you may go and borrow one of mine, but make sure you have a calculator handy. All right, why don't you pause the video now and try this next problem on your own. You should end up with 2700 degrees or 2700. Now these are talking about angle measures, so make sure you do have that little degree symbol to go along with this. All right, so we're going to talk a lot this chapter about different kinds of polygons. So if you're, we got one problem to do first. So the sum of the interior angle measures of a polygon is 1980. How can you find the number of sides in the polygon? Okay, well, we have our n minus 2 times 180 formula. That equals the sum of the interior angle measures. Well, right now, we don't know the number of sides, n, but we do know the sum, 1980. So instead of plugging a number in for n, we in fact want to plug a number in for our sum. You can say, well, 1980 is going to equal n minus 2 times 180. And now we have an algebra equation to solve. Now, many of you might see parentheses and go, distribute. I wouldn't recommend you do that. You can, it's just going to take you longer to finish the problem. What I would do is notice that these parentheses are being multiplied by 180 and nothing else is happening on that side of the equation. So what I can do to start off with is in fact just divide both sides by 180 and I get n minus 2 equals 11. Now I add 2, and I get n equals 13. The number of sides of in the polygon is 13. So we would say 13 sides. Make sure to interpret your answer when you're done. Don't just leave a 13. All right, so this chapter we're going to talk about various different types of polygons. If you're not sure what a polygon is yet, a polygon is just a multi-sided figure. So a triangle, a rectangle, a quadrilateral, a polygon, a parallelogram, a hexagon, a pentagon, all these different things. Now there's different kinds of polygons by the number of sides, but we also classify them by their angles and their side lengths. So we first have an equilateral polygon. That's a polygon where all the sides are the same length. You can see the congruent markers on this hexagon. Then we have an equiangular polygon, and that's a polygon when all the angles are congruent. And then last but not least, we have a regular polygon. And a regular polygon is both equilateral and equiangular. When you see a stop sign, you're seeing a regular polygon. All the angles are the same and all the sides are the same. So if you have a regular polygon where all the sides and all the angles are the same, then each inside angle is the same. So we can take that formula from earlier, our n minus 2 times 180, which tells you how much all these little red angles add up to, and if they're all the same, we divide it by the number of angles that there are. So we're going to use that to figure out some angle measures down here. It says the common housefly has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. What is the measure of each interior angle in one hexagonal facet? Well, if you don't know what a hexagon is, this one does give you a picture. You can count it. It has 1, 2, 3, 4, 5, 6 sides. And it's a regular hexagon, which means all the sides are the same, as are all those angle measures. So I would probably put little markings on there. So if we want to find the measure of an interior angle, well, we can find the sum and divide it by the number of angles they are. So we can use our n minus 2 times 180 formula earlier, and then just divide it by the fact that I have n angles. Well, a hexagon, we counted, has 6 sides, so we go 6 minus 2 times 180, divide it all by 6. Now, I would really recommend that if you're using a calculator, do 6 minus 2 first, then multiply by 180, and then divide by 6. In between each of those, I would actually hit equal. So I'm going to do this like that myself. 6 minus 2 is 4. I then have 4 times 180 over 6. I'm going to go 4 times 180. Enter. I get 720. Now I divide it by 6, and I get 120 degrees. That means each one of these little angle measures up here, each one of these is 120 degrees. All right, so we can use both of these formulas to find missing angle measures in polygons. Here you have a polygon that's in fact a pentagon. Pentagon means 5 sides, and its name is TODAY. You can see that we're looking for angle Y. We don't know how much it is, but we do know the other 4 angles in this pentagon. Well, this isn't a regular pentagon because all the angle measures are different. So we're not going to use our second equation, n minus 2 times 180 over n. We're going to stick with just our first equation, n minus 2 times 180. Because much like a triangle, all the angles add up to 180, and a pentagon, all the angles add up to something as well. We just have to figure out how much it is. So a pentagon has 5 sides. We plug that in. We get 3 times 180, which is in fact 540 degrees. What you want to do next is add up the 4 angles they gave you. They gave me 110 degrees at T, 120 at D, 150 at A, and you can see that it's a right angle at O, so that's 90 degrees. Add all 4 of those up, and we get 470 degrees. Well, we have 470 degrees already accounted for. We need 540 total. We're just going to take our 540, subtract the 470, and we will have our missing angle, 70 degrees. So the measure of angle Y equals 70 degrees. Why don't you pause the video now and try this next one on your own? It's very similar. All right, check your work with mine. I said this is a quadrilateral, 4 sides. The angles all add up to 360. The 3 angles I have add up to 258. I subtracted 258 from 360 and ended up with angle G being 102 degrees. So this completes the first half of our objective today to talk about the interior angles of a polygon. The next thing we need to talk about are the exterior angles of a polygon. So what we can actually do is, we've done this before, we can actually take a side of the polygon and extend it out to create what we call an exterior angle. My exterior angle measures are all in red up there. And in fact, there's this really cool relationship you can see in both these pictures that if you add up all those exterior angles, you get 360 in a triangle and in a quadrilateral as well. And in fact, that's true for every single polygon. The sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. No matter the number of sides it has, all of those exterior angles add up 360 degrees. Why, in fact, is this useful? Well, sometimes it's because this formula is so simple, it can actually be easier to find exterior angles in order to find interior angles. If we look at this problem here, there's two ways to do this one. It says, what is the measure of angle 1 in the regular octagon at the right? The key to this problem is regular. A regular octagon means every single one of those sides are the same and every single one of those angles are the same. So I can put little 1 congruent markers on all these sides. I can do the same thing on all of these angles. Now, if all of the inside angles are the same, it means that all of the outside angles are also the same because they make a straight line. But they should each have 2 red marks because they're not the same as the blue, just the same as each other. So, it gives you a little hint here. By the polygon exterior angle sum theorem, the sum of the exterior angles is 360. But since this octagon is regular, the interior angles are congruent, so their supplements, the exterior angles, are also congruent. We know all of these exterior angles, 1 through 8, all add up to 360, but we also know they're the same. If they're the same and they add up to 360, we can just go 360 divided by the number of sides, which is n, and we know that the number of sides is in fact 8. We go 360 divided by 8, and we get 45 degrees. The measure of angle 1 equals 45 degrees. This is the method of using our exterior angle theorem. We could also solve this using our interior angle theorem. This is a regular polygon, which means we can go n minus 2 times 180 all over n. That'll get us one of those blue angles. We go 8 minus 2, all times 180, all over 8. So 6 times 180 all over 8. We simplify that and we end up with 135 degrees. And you'd be like, wait, but 135 and 45 are different. Yes, because 135 is the measure of one of those blue angles. You can see that the blue and the red angle make a straight line, so if you go 180 minus 35, you will in fact get 45 degrees. Now, you can see one of these was much faster than the other. That's why we have this exterior angle theorem. Now, both of these things only work, this dividing by n, if we have a regular polygon, which means all the sides and all the angles are the same. And this was lesson 6.1. Our goals: to find the sum of the interior angle measures of a polygon and to find the sum of the measures of the exterior angles of a polygon. This was lesson 6.1, geometry.